When we look at Mars today, we see a dry and lifeless world. Its surface is dusty, barren, and covered in red sand. A frozen desert that seems completely uninhabitable. But to truly understand Mars, we also need to look into its past. Because billions of years ago, Mars may have been very different from the planet we see today. In fact, recent discoveries suggest that Mars once had vast amounts of water. The biggest question is, where did all that water go? NASA's NASA Perseverance rover has been exploring the ancient history of Mars. Its mission focuses on an area called Jezero Crater, a region scientists believe was once an ancient river delta. And what Perseverance discovered there is extraordinary. Scientists found evidence of a much older and larger river system hidden beneath the surface of Mars. This discovery was made using a ground-penetrating radar instrument called RIMFAX. The radar is capable of scanning layers beneath the Martian surface to depths of dozens of meters. The data revealed signs of an ancient buried delta that existed long before the visible delta seen on the surface today. Researchers now believe that water on Mars did not exist for only a short period of time. Instead, water may have flowed across the planet in multiple phases over very long periods. Based on geological analysis, the river system inside Jezero Crater likely formed during the Noachian period, around 4.2 to 3.7 billion years ago. Geomicrobiologist Emily Cardarelli from the University of California, Los Angeles explained that the RIMFAX data shows the ancient water system was far more extensive than scientists previously observed from orbit. Between September 2023 and February 2024, Perseverance completed dozens of traverses and collected radar data across more than 6 kilometers of terrain. The radar successfully penetrated over 35 meters below the surface. What scientists found beneath the ground was remarkable. The subsurface layers contain tilted rock formations similar to structures found on Earth that are created by sediment deposited by flowing rivers. Researchers also identified channel-like structures, lobate sediment deposits, and large buried boulders. All of these are classic signs of ancient river systems. Combined measurements suggest that some geological units beneath Jezero Crater may be between 80 and 90 meters thick. Scientists believe these layers formed through repeated episodes of flowing water, followed by periods of erosion over millions of years. Some of the detected features range from small formations to structures stretching hundreds of meters in length. This reveals that Mars once had a highly complex and dynamic river environment. These discoveries strengthen the idea that ancient Mars may once have been capable of supporting life. Where liquid water exists for long periods of time, the possibility of microbial life becomes much greater. Even more exciting, some of the sedimentary structures discovered in Jezero Crater could preserve traces of ancient biosignatures, chemical or geological evidence left behind by past life. Scientists now believe that the subsurface environment beneath Jezero Crater may once have been habitable for microorganisms. While no direct evidence of life has been found yet, Mars continues to show signs that it may once have been a living world. So what happened? Why did Mars transform from a wet planet into the cold desert we see today? Scientists believe the answer lies deep inside the planet itself. Unlike Earth, Mars is much smaller. Over time, its internal heat cooled rapidly, causing the motion inside its core to slow down and eventually stop around 4 billion years ago. As a result, Mars lost its global magnetic field. On Earth, the magnetic field acts like a protective shield, blocking harmful charged particles from the Sun. Without that protection, Mars became vulnerable to the solar wind, a continuous stream of high-energy particles flowing from the Sun. Over millions of years, the solar wind slowly stripped away Mars's atmosphere molecule by molecule. NASA's MAVEN mission confirmed that this atmospheric loss played a major role in transforming the planet. As the atmosphere became thinner, Surface pressure dropped, temperatures became colder, and liquid water could no longer remain stable. Eventually, much of the remaining water either froze beneath the surface or escaped into space. And over billions of years, Mars became the dry and frozen planet we know today. Mars was not always a dead world. Long ago, it may have had rivers, lakes, and a complex water system similar to early Earth. The discoveries made by Perseverance continue to reveal a planet with a rich and complicated history, a world that may once have had the conditions necessary for life. Today, Mars appears silent and empty, but beneath its surface, the secrets of its watery past may still remain hidden.